This next example is more kinematics practice. Consider if I had a runner who went 3 kilometers, and we'll try to be careful about significant digits, 3.0 kilometers in 9 minutes, and then walked back slowly that same distance in 35 minutes. There are lots of questions we can answer with this using kinematics. So let's say I wanted her average velocity for the first 9 minutes. So average velocity, usually a bar for average, for the first 9 minutes. How do I go about that? Well, using kinematics, I could say that's her change in position over how long it took for her to do that. So that would be 3.0 kilometers in 9 minutes. But I don't know many people who talk about speeds in kilometers per minute. They might say kilometers per hour. So let's see if we can get that to be helpful. So we need to know how many hours 9 minutes is. We do dimensional analysis, which I talked about in another video from this week. I need to get to hours, so I need hours on top. There's 60 minutes in an hour. So this would be 9 over 60 hours, which is about 1.15 hours. So this would become 3.4 kilometers in 0.15 hours. And if I do that division, that is 20 kilometers per hour. We could then ask what's her average velocity for the time spent walking. Well, implicitly, when I did this, I declared that this way was positive. Because if you think about this, it's a positive 3. So now if we're talking about velocity, we're concerned with direction. So that means our delta x is now going to be negative 3. So we walked in the negative direction. Negative, this is v bar in 35 minutes. Negative 3 kilometers in 35 minutes. And I have that same problem that no one really talks about, kilometers per minute. So 35 minutes. Let's convert to hours. We get about 0.58 hours. That would be negative 3 kilometers in 0.58 hours. Get negative 5.17 kilometers per hour. And if you kept more digits, you'd probably get something slightly smaller, but I was trying to be careful about my significant figures. I knew about 3 kilometers, 3.0. If I'd been really careful, this is only one significant digit, so my rounding there was bad. I should have only kept 1 decimal. Here I should keep 2 decimals, because we did know 2 decimals for each initial figure given. But I do know that sometimes WebAssign doesn't quite seem to understand significant figures, so you may need to keep a few more digits if you're doing this problem on WebAssign. What is the average velocity for the whole trip? So average velocity total. It's really tempting maybe to try to use these 2 numbers somehow. Since we're talking about averages, maybe I want to average them. It's wrong. Remember, velocity is change in position as a vector, or change in time, and my change in position as a vector was 0. I started and ended at the same place if I'm talking about that total time, so that is 0 over our total time of 44 minutes, which is obviously 0. But if I wanted to ask what's the average speed for the whole trip, well, that is my total distance covered divided by my total time, which would be 6 kilometers in 44 minutes. And that same problem again, let's change this to hours. 44 minutes times 60 minutes an hour. What do I get? 0.73 hours. So now our average speed, that's really a weird way to say that, isn't it? Average speed total. What I meant was for the full 44 minutes. So that would be 6 kilometers in 0.73 hours. And if I do that, kilometers per hour. And again, if you follow these steps on a similar WebAssign problem, and it tells you you're off by a little bit, you may just need to keep more digits. I'm trying to be careful about significant digits, but I have noticed that WebAssign doesn't always do great with them.